All right, our next adventure in this particular chapter deals with derivatives of inverse trig functions. And what we define as an inverse trig function is, if you recall, when we did some calculations in other classes, there are times in which we had to use inverse functions. Like when we're trying, we know that the sine of 30 degrees is 0.5, or the sine of pi over 6 is 0.5. Then if we wanted to find the angle, we would take the value of that sine and say the inverse sine of 0.5 is 30 degrees, or the inverse sine of 0.5 is pi over 6 radians. The term they use for that is arc sine instead of inverse sine. Arc almost means archaic because they still adhere to this, but the calculators don't use arc. They use sine -1 power of the value. But it's the same thing. And so we can derive these inverse functions by dealing with these formulas. Now, there are derivations for this that we could go through. And again, I'm not sure what your college professor is going to ask you to know or not know, or use or not use, as far as tables are concerned. But you can look these up where they get these from. Right now, again, my concern is getting you to be able to be mathematically savvy in manipulating problems such that you come up with a solid final answer. So this is Theorem 516 in your book. It lists these 6 inverse functions going from sine to cosine in their inverses, which are arc sine to arc or cosecant, rather not cosine. So we have to be able to determine our chain rule. What is our u? What is our u prime? It's just like we've done with other problems up to this point. So, like I said, this is an exercise in manipulation, trying to get it to fit these patterns. And you'll see me use that phrase at times as fitting such and such a pattern. Like, it fits pattern 5, 16, 1. And in your book, this is number 1, 2, 3, 4, 5, 6, all the way down. And so that's what we're trying to do. We're trying to find the pattern that fits this derivation, and in the next section, integration, and then go from there. Okay? So let's take a look at some odd number problems that are related to the even number problems that you are going to be doing. This page 378 is where we're doing this. The problem is the function of 2 times the arc sine of x minus 1, and we're asked to find the derivative of this. So I have substituted u for x minus 1, and when you derive u, that's just going to give you the derivative of x, which is 1 times dx. Okay? So, in this case here, since we have 2 arc sine x minus 1, the 2 is to be separated. We're going to be deriving this because 2 is going to be, it's like the derivative of 2x is 2. So it's just 2 times whatever the derivative is. And the derivative according to 516.1 is u over the square root of 1 minus u squared. U prime over the square root of 1 minus u squared. Hopefully I'll put that up. Yeah, u prime. Okay? So a u prime is du, so that's going to put dx on top. And we said u is x minus 1. And so that's going to be the square root of 1 minus u squared. So that's going to be x minus 1 squared. And now it's just a matter of doing the mathematics for this. When you square x minus 1, you get x squared minus 2x plus 1. Subtract all that, change all the signs, so it becomes negative x squared plus 2x minus 1. The 1, the negative 1 cancels out. And we generally like to write our polynomials starting with a positive value. So we'll put 2x minus x squared, and 2 times dx is what we have on top. Or we could say we have 2 over the square root of 2x minus x squared dx. We can write it like that. Either way is fine. And so I'll probably be going back and forth between the two forms, most likely. So that's for number 41. 45, where I'm now being asked to find the derivative of the arctangent of x over a. And we're going to be using u is going to be x over a. du would be the derivative of x over a, or 1 over a times dx. And according to 516, the derivative of arctangent of u is u prime over 1 plus u squared. So now I plug in the values for u prime and u squared. Well, I get 1 over a times dx over 1 plus, and then we said u is x over a, so it's x over a quantity squared, and which of course is x squared over a squared. Now I'm going to make one whole fraction in the denominator. Lowest common denominator is a squared, so the numerator becomes a squared plus x squared. And now I'm going to be able to divide these two fractions by multiplying by the reciprocal of this fraction right here. So this becomes a squared over a squared plus x squared. And this is still 1 over a times dx in the numerator. So I'll multiply these three together. And an a cancels out here, leaves 1a on top. And our answer is a over a squared plus x squared times dx. Number 49. The function here is given to us as the sine of the arc, cosine, and tangent. Now, in the previous lesson we had here, when we had a situation like this, we needed to find the sine by looking at the right triangle geometry for this. We identify sine as opposite over hypotenuse. Cosine, of course, is adjacent over hypotenuse. And since that is the value of the angle cosine is t over 1, that means that we're going to put t for the adjacent and 1 for the hypotenuse. Use Pythagorean theorem. 1 squared equals t squared plus the opposite squared. And so I subtract t squared and take the square root of both sides. And that makes the opposite equal to the square root of 1 minus t squared. So the sine of the arc, cosine, and tangent is going to be 1, the opposite, which is the square root of 1 minus t squared, over the hypotenuse, which is 1. And of course the 1 basically disappears and gives you the square root of 1 minus t squared. So that means then that h sub t is equal to this quantity right here. And now we can find the derivative of that quantity. This is 1 minus t squared to the 1/2 power. So put the 1/2 there and then kick this down to negative 1/2 because we subtract 1/2 minus 1. And then times the derivative inside the radical there, which is the negative 2t. So 1/2 and 2 cancel out to leave us the negative t here. And this remains as 1 minus t squared to the negative 1/2 power. So that means this is going to be a negative fraction, t will be in the numerator, and the square root of 1 minus t squared will be in the denominator. And there you have it.